We will go over translation in a lot more detail, but for now I just wanted to introduce the basic concepts. So first of all, the actual translation itself occurs in ribosomes. And so ribosomes are going to take the mRNA, the protein coding portion, protein coding RNA, and interpret it using the tRNA. So it's going to translate the mRNA to protein using a tRNA intermediary. And the important part to see in this tRNA process is that there are there's this processivity of the actual of what's happening. So mRNA is grabbed by the 5' end and then read 5' to 3', which is kind of counter to the process of transcription, but just recognize that the 5' is where the process begins, and it reads it 5' to 3'. And so what ends up happening is the ribosome will grab onto a tRNA, and that tRNA is going to be charged. So here's an example of a charged tRNA over on the right with a particular amino acid. It's then going to bring that tRNA into the mRNA, so you're going to have the sort of coding part of complementary codon to the coding mRNA, and then it's going to grab the growing polypeptide chain from a tRNA that's already present in the ribosome and add it onto the amino acid that the tRNA that it just introduced into the ribosome. Having done that, it will then release the now uncharged tRNA out of the ribosome and move the other tRNA that now has the growing polypeptide chain forward in the process, and then again reintroduce a new tRNA into the translational machinery. So I'm going to represent this on the next slide using very similar methods. So there's not going to be any audio in the next one. So a question then is, do bacteria have ribosomes? So we've talked a lot about how eukaryotes and prokaryotes are a little different. Eukaryotes have a nucleus, prokaryotes do not. So question is then, do bacteria have ribosomes? Yes. In order to actually translate mRNA into protein, you have to have ribosomes. And so they have their own types of ribosomes that are just a little different than ours, but